everybody, welcome back to my YouTube channel. This is Sir Raubensun and today we are going to learn about limit at infinity. But before I begin my discussion in this video, do not forget to click the subscribe button and give me a thumbs up if you like my video. Okay, so let's discuss it one by one. So for rule number one, whenever we are going to encounter the limitation of f of x all over g of x as x approaches to either positive or negative infinite, take note that f of x here and g of x are polynomial functions. Okay, so for rule number one, what are we going to do is we are going to compare the degrees of our polynomial function. That is the best way to identify what is the limit of our function. For rule number one, what if the degree of numerator is less than the degree of denominator? What is the limit of that function? So meaning for rule number one, your limit or the function looks like this. The limitation of 5x squared plus 3x minus 2 all over x cubed plus 3x minus 1 as x approaches to either positive or negative infinite. What are you going to do is to locate the leading coefficient. For the leading coefficient of our numerator, that is 5x squared. What is leading coefficient? When we say leading coefficient, that is the term in your polynomial which consists the highest power or the highest exponent. For our numerator, the leading coefficient is 5x squared because 5x squared consists of the highest power. That's good. For our denominator, our leading coefficient is 3x cubed because 3x cubed consists of the highest power. So as you can observe, the leading coefficient or the power or the degree of our denominator is greater than the degree of our numerator. Meaning, we have it is applicable to rule number one where the degree of numerator is less than the degree of denominator. What is the limit of that function where your x approaches to either positive or negative infinite? Once you encounter that kind of problem, the limit of that function is automatically equal to 0. Okay? Again and again, if the degree of the numerator is less than the degree of denominator as your x approaches to positive or negative infinite, automatically the limit of that function is equal to 0. Am I clear to everyone? That's good. So this time we are going to talk about the rule number 2 for limit at infinity. For rule number 2, what if the degree of your numerator is equal to the degree of your denominator? What is the limitation of that function in the form of limitation of f of x all over g of x as x approaches to either positive or negative infinite? Again and again, take note that f of x and g of x here are polynomial function. So what are you going to do? You are going to compare the leading coefficient. Same for rule number 1. Say for example, I have this example, the limitation of 5x4 plus 3x minus 2 all over 3x4 plus 3x minus 1 as your x approaches to either positive or negative infinite. What is the limitation of that function? As you can observe, the leading coefficient for our numerator is 3x4 because it consists the highest power among other terms in the numerator. For denominator, the leading coefficient is 3x4 because it consists the highest degree among the terms in the denominator. As you can observe, the degree in the numerator is 4 and the degree in the denominator is 4, and obviously 4 is equal to 4 and it is applicable for the rule number 2. What is now the limit? What if the degree of the numerator is equal to the degree of denominator? What is the best way to solve this problem? What are you going to do is to simply cancel everything out because it will never help you solve the problem. It is the best way to identify the limit, just a mere inspection. You cancel other terms and what are you going to do is to only get the leading coefficient. It will become the limitation of 5x4 all over x4 as x approaches to either positive or negative infinite. What can you observe is that 5x4 divided by x4, that is cancelled. Okay, you can cancel x4 to our term. So meaning you can cancel this one. What is the remaining in the denominator? That is 1. And 5 divided by 1, that is 5. That's great. So that is the limitation of 5 as x approaches to positive or negative infinite. As you can observe, the remaining value now is 5, and that is constant rule. The limitation of 5 as x approaches to positive or negative infinite, that is equal to 5. Meaning, how are you going to solve if the limit of the function approaches to positive and negative infinite and the leading coefficient are equal in both numerator and denominator? What are you going to do is to simply get the numerical coefficient of the leading coefficient. So here our leading coefficient is 5. You get 5. Okay? And for the denominator, the numerical coefficient is 1. So meaning that is x4. So you only get 1. So 5 divided by 1, that is 5. So meaning the limitation is equal to 5. Am I clear to everyone? That's great. We are down to our last rule for limit at infinity. That is rule number 3. What if the degree of the numerator is greater than the degree of the denominator? So again and again, in this video, we are dealing polynomial functions. So meaning the limit of f of x all over g of x, where f of x and g of x are polynomial functions as your x approaches to either positive or negative infinite. So let's try to find the limit of the function by a mere inspection. So say for example, I have here the limitation of 3x cubed plus 3x all over 2x minus 1. Same thing that we did in our previous rule 1 and rule 2. Let's know what is the leading coefficient. And our leading coefficient here is 3x cubed because x cubed consists the highest power or the highest exponent among other terms. And for denominator, the leading coefficient is 2x because 2x consists the highest power among other terms, where your x approaches to negative infinite. In this example, what are we going to do is to consider only the leading coefficient, and let's try to cancel all other terms which is not the leading coefficient. For the denominator and numerator, let's cancel that one. What are we going to do is to only get those leading coefficient, and it will become the limitation of 3x cubed all over 2x as x approaches to negative infinite. Okay, same thing that we did is we have to simplify this once, because once you substitute it directly to your x's, it will become indeterminate form. And take note that infinite over infinite is still indeterminate form. What are we going to do? Let's review what we've learned in our junior high school. How are we going to simplify this one? Take note that we have 3x's. It will become 3 times x times x times x. And for our denominator, that is 2 times x. And obviously, we can cancel x and x. So what is the remaining value for our numerator? That is the limitation of 3x squared all over 2x as x approaches to negative infinite. Let's continue simplifying this example. So now we can obviously we can able to write this problem as the limitation of 3 over 2 x squared as x approaches to negative infinite. And obviously this form is discussed in our previous example, that is 3 over 2, that is considered to be our constant and x squared. We all know once we put a negative number in our variable, exponent is even. We say for example this one, negative, how many x do we have? We have 2, so we have to multiply negative infinite twice. Negative infinite times negative infinite, that is positive infinite, and positive infinite multiplied to any positive constant, that is positive times positive. Very good, that is positive infinite. So unlike other rule number 1 and number 2, we can able to answer that one by a mere inspection. This time we can able to answer that by a mere inspection, but we have to simplify as we simplify our function. Okay, so meaning number 3, the degree of your numerator is greater than the degree of your denominator. So meaning we have two possible answer, that is positive infinite and negative infinite. And that ends the rule, 3 rules for the limit at infinity, considering that we have the rational function f of x over g of x, where f of x and g of x are rational functions. Okay, for my next video, we are going to discuss examples. Okay, examples as application to my previous rules. Okay, so thank you so much for watching this video. If you like this video, do not forget to click the subscribe button and give me a thumbs up if my video helps you. Okay, so see you in my next video. Bye bye.